Myself, Dr. K. Viswanath Allamraju, Department of Mechanical Engineering, Institute of Aeronautical Engineering, Dundigal, Hyderabad. In this session, we are going to solve problems on motion of circular motion, that is motion of rotation. So before going to start, we have to learn certain things, certain important terms such as the angular velocity and angular acceleration, etc. First, the angular velocity, it is rate of change of angular displacement theta of your body and is expressed in terms of RPM, that is revolutions per minute. The unit for angular velocity is radians per second and it is denoted by omega. Okay, and here angular velocity is there is a relation between linear velocity and angular velocity. The relation between linear velocity and angular velocity is linear velocity equal to in terms of angular, that is r times omega. This where v is the linear velocity, r is the radius, and omega is the angular velocity. The angular velocity is in radians per second, whereas v is in meter per second. So here v unit for v is meter per second, r is in meters, where omega is in radians per second. Okay, and the next term is called angular acceleration. What is the angular acceleration? Rate of change of angular velocity, that is d omega by dt, is known as angular acceleration. This angular acceleration is radians per square second. Okay, and usually it is denoted by alpha, and it may be constant or variable here. So angular velocity, angular acceleration alpha equal to d omega by dt. Now, okay, this angular acceleration, that is alpha equal to d omega dt. What is the unit for this angular acceleration? That is radians per square second. Okay, and here one more thing is the angular displacement. The angular displacement is the total angle through which a body has been rotated, and is usually denoted by angular displacement is in terms of theta, that is theta is the angular displacement. And the mathematically, if a body is rotating with a uniform velocity, with a uniform angular velocity, then in t seconds, then the angular displacement theta equal to omega times t. Theta equal to omega times t, where theta is the angular displacement. The angular displacement is in radians, and omega is the radians per second, t in seconds. That's why here the omega unit is radians per second multiplied by second. So second get cancelled. So the unit for angular displacement is in radians. Okay, and here, before going to start the equation of motion when the body is under circular motion or under rotation. So before going to start, we have already, let us recapitulate for linear motion equations. The equations for linear motion, that is final velocity v equal to u plus at, and s equal to ut plus of a t square. And here one more thing, v square equal to u square plus 2 times as. These are the equations of motion for the linear, not for rotation. It is on the ground. Whereas for angular motion is very simple. The final velocity for angular motion, here v for final velocity for linear. For angular motion, omega naught. Omega 0 is the initial angular velocity, and final angular velocity, that is the omega, is the final angular velocity. What about acceleration? Alpha is the acceleration, angular acceleration, constant angular acceleration in radians per square second. What about theta? Where t is the time for both the things is remains same. The time is the time taken by the particle to change its velocity from initial angular velocity to final angular velocity, that is omega 0 to omega. And whereas theta for total displacement, that is the angular displacement, total angular displacement in radians. Now we are going to write directly if you understand the equation of motion for the linear motion equations, in the place of final, you substitute final angular velocity. In the place of initial linear, you substitute as initial angular velocity, and the case of acceleration, substitute as alpha, that is the angular acceleration, that is v equal to u plus at for linear. For angular, that is omega equal to final angular velocity equal to initial angular velocity plus alpha times t. This is the equation of motion for rotation when the body is under rotation. Now you take it another equation, s equal to ut plus of at square, where the s is the linear displacement. Substitute as angular theta equal to u initial angular velocity omega 0 t plus of alpha times t square. Yes, this is another equation. And the final angular, that is another equation of linear, that is v square equal to u square plus 2as. What is the v for? That is the omega naught square, omega square equal to omega naught square plus 2 times alpha theta. This is another equation of motion, okay, when the body is under rotation. Okay, let us see now how to derive those equations here. As we mentioned here, that v equal to omega naught plus alpha t. This is in linear motion, that is in final angular velocity equal to initial angular velocity plus alpha times t. Another equation, this is the equation 1, and equation 2, s equal to ut plus of at square, that is theta equal to omega naught t plus half times alpha t square. And the third equation is omega square, that is v square, that is omega final angular velocity square equal to square of the initial angular velocity plus 2 times alpha times theta, angular displacement. What here again, once again, where is omega is final angular velocity, omega 0 is initial angular velocity, where alpha is angular acceleration, t for time, and theta for total angular displacement. The unit for theta is total angular displacement is radians, whereas the unit for final angular velocity is radians per second, and the unit for initial angular velocity is also for radians per second, and alpha angular acceleration, that is radians per square second, and t unit for t seconds, that is seconds. So theta, omega 0, omega naught, and alpha and t, these are the different equations. Okay, that is omega equal to omega naught plus alpha times t, theta equal to omega naught t plus half alpha t square, and omega square equal to omega naught square plus 2 times alpha times theta. By using these equations of motion when the body is under rotation, we are going to solve the problems. Let us begin. Now, before going to start solving the problem, there is a relation between the linear motion and angular motion, so that we can understand better in comparison, comparatively. So, this slide is so important so that we can understand, we can really correlate it between linear motion and angular motion. In the case of linear motion, the initial velocity for linear motion, the letter it is denoted by small letter u. For angular velocity, angular motion, it is omega 0. For final velocity v, for linear motion, for angular motion, what is the final velocity? Final velocity is omega. And for linear motion, acceleration is a, letter a, it is denoted by, for angular motion, it is alpha. Linear displacement s, for angular motion, angular displacement is theta. Formula for final velocity, that is v equal to u plus at, whereas for linear motion, for angular motion, that is omega equal to omega naught plus alpha times t, where is t for time. And formula for distance traversed, that is s equal to ut plus of at square for linear motion, and theta equal to omega naught t plus of times alpha t square for angular motion. Formula for final velocity, another formula for final velocity, that is v square equal to u square plus 2as for linear motion, and omega square equal to omega naught square plus 2 times alpha theta is for angular motion. Now, whereas for under variable acceleration consideration, that is differential equation formula for velocity, that is v equal to ds by dt, Whereas for in the case of V, that is omega equal to d theta upon dt, where d theta is change in angular displacement with respect to time, whereas a ds is the total distance, ds by dt, that is displacement, change in displacement by time. And differential formula for acceleration, whatever acceleration, a equal to rate of change of velocity, that is linear velocity, that is dv by dt, whereas for alpha equal to d omega by dt. Okay, after knowing this, let us begin to solve the problems. Yes, a flywheel starts from rest and revolves with an acceleration of 0.5 radians per square second. What will be its angular velocity and angular displacement after 10 seconds? Okay, after 10 seconds, a flywheel starts from rest. That means initial angular velocity omega 0 equal to 0. And with an acceleration alpha equal to 0.5 radians per square second. What will be the angular velocity? What will be its angular velocity and angular displacement? Its angular velocity and its angular displacement theta after time t second, 10 seconds. Okay, let us begin. Angular velocity of the flywheel. Okay, the angular velocity of the flywheel, final angular velocity omega equal to omega naught times omega naught plus alpha times t. Whereas omega naught equal to 0, that is initial, plus alpha, what is the acceleration? That is 0.5 radians per second. 0.5 radians per square second, 0.5, and times t. Substitute here, that is the 5 radians per second. That is the angular velocity of the flywheel after 10 seconds. The next object is the angular displacement of the velocity. What is the angular displacement of the flywheel? What is the angular which equation we are going to use? Theta equal to omega naught t plus half times alpha t square. That is the equation we are to use. That is theta equal to omega naught t plus half times alpha t square. Substitute omega naught is 0 and t is the 5 seconds, half times alpha is 0.5, again t equal to 10. Substitute over here and the obtained value, that is the 25 radians, that is the angular displacement of the flywheel. How can we know it? What are the linear equations or angular equations or angular circular motion, angular motion equations? Which equation? What are the type of equations? What type of equations we have to apply here? How can we know it? A flywheel is nothing but a rotating component which is used for storing the kinetic energy, torque. Now flywheel is used, okay, it is started revolving, already mentioned that words. So how to identify it, whether the problem is related to angular motion or not? There are so many clues are there. Let me discuss first. First term itself is flywheel. Flywheel itself indicates angular motion. Now, how can we know it? It is revolving. This revolving term also it denotes for angular motion. And one more thing, the acceleration, based on the unit for acceleration, it's for angular acceleration. Finally, we can understand, based on this data, we come to conclusion that it is the body is under angular motion. Okay. And objectives definitely related to, the objectives also directly mentioned here. These objectives angular velocity and angular displacement. From these two objectives also we can identify the body is under angular motion. Okay, let us. The next problem, a wheel, again it is rotating under angular motion, increases its speed from 45 revolutions per minute to 90 revolutions per minute. In what time? 30 seconds. Find, number one, angular acceleration of the wheel. What is number one? Find angular acceleration of the wheel, and that is alpha. The next objective is that the number of revolutions made by the wheel in these 30 seconds. The number of revolutions made by the wheel in this, that is angular displacement. Okay, number of revolutions made by the wheel. Now, this wheel is increasing its speed from 45 revolutions per minute to 90 rpm. That is the given data. So, how to find out? What are the equations we are going to calculate here? Let us begin with that given data, initial angular velocity. that is omega naught, that is 45 rpm revolutions per minute. That 1 revolutions per minute equal to pi radians per sec. Okay, 1 revolutions, how to make it? 1 omega naught, omega equal to 2 pi n by 60. Okay, that is 2 pi n by 60. That is initial omega naught, that is 2 pi n naught. Substitute over here 2 pi n naught. What is n naught? Is 45 by 60. That is 90 by 60. That is 1.5 pi radians per second. The next final angular velocity, that is omega equal to again 2 pi n by 60. 2 pi times what is the n? 90 by 60. Again 180, that is 3 pi. That is again 2 times 90. If you make it here, that is 3 pi. That is 3 pi radians per second. Now what is the time? Time t equal to 30 seconds. How to apply here first objective? The first objective is the angular acceleration of the wheel. So the angular acceleration of the wheel, what is the angular acceleration? It is denoted by alpha is the angular acceleration of the wheel. And whereas the angular velocity, we have to find out the final angular velocity of the wheel, that is omega. Now we know the equation, that is 3 pi equal to, that is a v, omega equal to omega naught plus omega equal to omega naught plus alpha times t. What is the omega here? The omega here it is, we need, that is the actually v equal to u plus 8s alpha times t. That omega equal to, that is 3 pi, final angular velocity, that is what 3 pi equal to, what is initial angular velocity? 1.5. Whereas omega is the final angular velocity. By plugging those values into this equation, the equation will be obtained in terms of alpha. Omega is 3 pi, omega naught is 1.5 pi, plus alpha is unknown, whatever t, time is 30 seconds. That is one of the equation. From this equation, whatever alpha equal to, the alpha equal to what? 3 pi minus 1.5 pi by 30. That is 0.05 pi radians per square second. That's what you're going to apply. That is alpha, angular acceleration of the wheel. What about the second objective? The second objective is that the number of revolutions made by the wheel in 30 seconds. What is the number of revolutions made by the wheel in 30 seconds? Okay, let us equation. We need angular displacement. So the total angle turned by the wheel in 30 seconds. That is the time t 30 seconds. The theta equal to theta equal to omega naught t plus half times alpha t square. Substitute over here omega naught, alpha and t, these values. So the omega naught equal to 1.5 pi and t equal to 30 seconds plus of alpha equal to 0.05 times pi, whereas t is 30 square. The calculated value is 67.5 pi radians. That is in radians. Okay. We have to convert this radians into revolutions per minute in revolutions. 1 revolution equal to how many radians? 1 revolution equal to 360 degrees. So, how many radians? That is 2 pi, 2 times pi equal to 182, 2 pi radians. Now here 1 revolution equal to 2 pi radians. Now substitute here 67.5 pi by 2 pi. So here 2 pi radians, 1 revolution equal to 2 pi radians. Then 67.5 times pi equal to how many revolutions? So from this 67.5 times pi by 2 pi, that is what? They obtained a value is 33.75 revolutions. Theta equal to 33.75 revolutions. That is the angular turned by the wheel. It is nothing but what? Angular displacement. Okay. The angular displacement, it turned in terms of revolution, that is 33.75 revolution. How many degrees? Okay, radians. Again, you make it, that is 67.5 times pi radians. Okay. Now, the another problem here, a pulley starting from rest is given an acceleration of 0.5 radians per square second. What will be its speed in RPM at the end of 2 minutes? If it is uniformly retarded at the rate of 0.3 radians per square second, in how many minutes the pulley will come to rest? This is what we need here. Once again, if you want to read again, because so that what are the objective, what are the given data, what to be found out, we can catch easily. Now here, first of all, we are considering the angular momentum of pulley from rest. So in this case, the given data initial angular velocity is whatever it is starting from rest. From rest means omega naught equal to 0. And alpha 1 angular acceleration for alpha 1 equal to 0.5 radians per square second. And what is the time taken? That is for 2 minutes. 1 minute equal to 60 seconds. 2 minutes means 2 times 60, that is 120 seconds. Now, angular speed of pulley in RPM at the end of 2 minutes. That is the first objective. Now, final angular velocity. What is the final angular velocity? That is omega equal to omega naught plus alpha times T1. What is the omega naught? 0 plus alpha 0.5 times T1 120. That is 60 radians per second. The 60 radians per second convert into 60 revolutions per second. That is 60 by 2y. That is 69.55 RPS. Now, 1 revolutions RPS equal to 60 in minutes. This per second. Per minute how many? So, 9.55 times 60. That is 573 revolutions per minute. That is the angular velocity, angular speed of pulley in revolutions per minute, RPM. In RPM here it is. Okay. In RPM we need. That's why we calculated the final angular velocity that is radians per second is converted into revolutions per minute, that is 573 revolutions per minute. So here the revolutions per minute, final angular speed came out in terms of revolutions per minute, but it is nothing but what is that RPM? That is angular speed. It is known, okay, 573 revolutions per minute. If you want, you can convert back in radians per second. Okay, based on the what was asked, that to be found out, for that what we did, we converted this radians per second into revolutions per minute by dividing with the 2 pi and multiplying with 60 for that the given answer. Okay, now the next time in which the pulley will come to rest. What is the time in which the pulley come to rest? That T2 is the time in which the pulley come to rest. Now consider the angular motion of the pulley in coming to rest. In this case, the initial angular velocity is 60 radians per second. Initial angular velocity is 60 radians per second. And the final angular velocity omega equal to 0. Now retardation alpha t equal to 0. Negative, that is retardation, that is 0.3 radians per square second. That is negative. Why it is negative? Because of retardation. Okay. Now the final velocity of the pulley, that is the what is the formula for this? Omega equal to omega naught plus alpha times T2. Where is the omega equal to 0, omega naught is 60 and alpha is minus negative 0.3 times T2. From the T2 can be calculated 60 by 0.3. Okay, 600 by 3, that is under 200 seconds. Okay, divided by 60, if we make it, what will happen? It comes in terms of minutes. Okay, we need only seconds, that is 200 seconds. Okay, next, the next problem is that under rotary motion condition, a wheel rotates for 5 seconds with a constant angular acceleration and it describes this time, that is 100 radians. It then rotates with a constant angular velocity and during the next 5 seconds it describes 80 radians. Find the initial angular velocity and the angular acceleration. Find the initial angular velocity and the angular acceleration. Now the solution here, it is the given time t equal to 5 seconds. And also one more thing, angular displacement, that is for 100 radians. Okay. Now the first objective, that is initial angular velocity, is first of all consider the angular motion of the wheel with constant acceleration for 5 seconds. Now theta equal to omega naught t plus half times alpha t square. We know the equation, half times alpha t square. For the theta equal to radians, that is angular displacement was given 100 equal to omega naught times t 5 plus half times alpha t square 5. Now here the equation obtained here it is. After simplification, omega 40 equal to 2 times omega naught plus 5 alpha. Okay. Now another equation here. Omega equal to omega naught plus half time plus alpha t, omega naught plus alpha t equal to 5. That is omega naught plus 5 alpha. Now consider the angular motion of the wheel with a constant angular velocity of omega naught plus 5 alpha for 5 seconds, and it describes what, how many radians? 80 radians. Now the angular displacement 80 equal to, again angular displacement equal to 80 equal to 5 times omega naught plus 5 alpha. Okay, 5, what is the angular theta equal to, angular displacement theta equal to omega times t. What is the omega? This is the omega. Whatever time t, 5 seconds. Substitute over here, that is 16 equal to omega naught plus 5 alpha. This is one equation and here it is another equation. By using these two equations, we can calculate omega naught and alpha, that is initial angular velocity and also acceleration. Now by using those two equations, the obtained value is omega naught equal to 24 radians per second. Substitute this 24 radians per second in one of the equation, then you will get it angular acceleration. That is alpha is 1.6 radians per second square second in negative value. That means what is this alpha? Alpha is retardation. Angular, it's not acceleration, it is retardation. That is the angular retardation, that is 1.6 radians per square second. Now, there are some of unsolved problems. How to solve it? These are the answers. Please try at home and you'll get it for practicing. Let me discuss one by one these problems also. I'll discuss how to solve. Now, a flywheel increases its speed from 30 revolutions per minute to 60 revolutions per minute. What is 30 revolutions per minute? Initial angular velocity, that is omega naught equal to 2 pi n naught by 60. That is 2 pi times what is n naught? 30 by 60. We will get in omega naught in radians per second. Next, omega is final angular velocity 2 pi n by 60. 2 pi times n, 60 by 60. That is in terms of 2 pi. Here it is 2. This is the pi radians. This is pi radians per second. Here it is 2 pi radians per second. Now in 10 seconds, t equal to 10 seconds. Now calculate the angular acceleration. What is angular acceleration? Alpha we need. How to get alpha equal to how much? And also number of revolutions made by the wheel in these 10 seconds. Angular displacement. We already solved this model. Yes, I'm going to here introduce that model. This is the initial angular velocity. Yes, this is the model. It is related to that model. That problem is related to this solved problem. You can solve it exactly as it is. Here 4590, there it is different numericals. Okay. That is 30 to 60. There 45 to 90, here it is 30 to 60. Then it is obtained as pi by 10 radians per square second, alpha, and also 7.5 revolutions. Okay, anyhow, what is the problem here? How to apply it? Omega equal to omega naught plus alpha times t. This is one equation you obtain. You use it, you will get it alpha. Next, theta equal to omega naught t plus half times alpha t square. Substitute this obtained alpha and the time t, omega naught, everything. This comes in radians. Convert into what? Revolutions. Okay. 1 revolution equal to 2 pi radians. Therefore, divided by with the 2 pi, then you will get it revolutions. Alright. The next problem, so unsolved problem here, how to begin it. This is also solved here. A wheel starting from rest is accelerated at the rate of 5 radians per square second for a period of 10 seconds. It is then made to stop in the next 5 seconds by applying brakes. Find maximum velocity attained by the wheel and total angle turned by the wheel. How to begin? Again, this begins starting from rest. That is omega naught equal to 0. And omega equal to accelerated at the rate of, it is accelerated at the rate of 5 radians per second for radians per square second. That means here what is given? Alpha equal to 5 radians per square second for a period of 10 seconds. So t equal to 10 seconds. It is then made to stop in the next 5 seconds by applying brakes. Okay, T1 and T2. Find the maximum velocity attained by the wheel. What is the maximum attained by the wheel? That is the final angular velocity. And also total angle turned by the wheel. What is the angle turned? That is angular displacement. Okay, these are the two objectives we have to calculate. Two objectives. Apply those equations of motion. One of the equation. Okay, what is the time here? Omega. Omega equal to omega naught plus alpha times t, one of the equation. Another equation, theta equal to omega naught t plus half times alpha t square. By using these two equations of motion, when the body is under rotation, you can get it, this omega and theta, that is angular velocity, final angular velocity, and also total angle turned by the wheel. Alright. Now third problem is that a wheel is running at a constant speed of 360 revolutions per minute. At what constant rate in radians per second its motion must be retarded to bring the wheel to rest in 1, 2 minutes and 2, 18 revolution. So try by equations of motions. Okay, the given data is constant speed 360 revolutions per minute and angular, and also at what constant rate its motion must be retarded to bring the wheel to rest. Okay, that is means angular acceleration of two angular accelerations are to be calculated. Alpha 1, alpha 2, initial and final. Yeah, these are the two things are to be calculated. Okay, in summary, let us begin. We covered what we covered in this session. We covered what is angular motion, what are the terms, angular velocity and angular acceleration and angular displacement, and equation of motion when the body is under rotation, under angular motion, that is omega equal to omega naught plus alpha times t, and theta equal to omega naught t plus of alpha t square, and omega square equal to omega naught square plus 2 times alpha theta. By using those three equations, mostly we use first two equations out of 3 and solve the problems and got the results such as angular displacement calculations in terms of RPS, revolutions per minute, or in terms of revolutions, in terms of radians, and angular acceleration and angular velocities. Okay, in this session we used references R.S. Kurmi for engine mechanics by R.S. Kurmi, and engine mechanics by Irving Shames, engine mechanics by Hibbeler, engine mechanics by Beal and Johnston. Of course, it is a vector mechanics. We use the concepts. With this, we can end the session. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.